All right, so today we're going to continue talking about how to fill in the unit circle. So we've already got quadrant 1 filled in that we may have done in the 1 section in our notes. This would be a good time to pause the video and kind of copy this over to quadrant 1 on the full unit circle. But things to remember, our unit circle is centered at 0, 0 and has a radius of 1 unit. Okay, so we're going to use these dashed lines to fill in all of our degree measures. So let's do that first with all of our other quadrants. And the easiest way to do that is to note that all of these angle markers that aren't kind of in the center of the quadrant are all multiples of 30 degrees, right? 30, 60, 90, etc. So we're going to kind of skip over the ones in the very middle, but we will be able to fill in all of these by doing multiples of 30. So we have 30, 60, 90, adding 30 again, we get 120. Skip the middle, because that's actually a multiple of 45. So this one would be 150. Another 30 degrees is 180. Another 30 is 210. Skip the middle, because that's a multiple of 45. So adding 30 again, we're at 240. This is 270. 300. Skip the middle, 330. And then 360. And we've come full circle. Okay, now all the ones in the middle are multiples of 45. So 45, 90, add another 45, we get 135. Plus 45 would be 180. Add 45 to that, we get 225. Skip down to 270, add another 45, and we're at 315. Okay, another way of also filling in those 45-degree angles is you might note that it is 15 degrees more than the angle before it, right, in each of these, or 15 degrees less than the one after it, right? But it's kind of halfway between them. But now we filled in all of the angle measures on the unit circle. The next thing we want to fill in is all the radian measures. And the easiest way to do this is to actually start with 90. Do all your multiples of 90. So every 90 degrees, we get another pi over 2. So you can think of this as 1 pi over 2. When we go another 90 degrees, we get 2 pi over 2, which of course reduces to 1 pi. And we should remember that, right? From our conversions, pi radians is 180 degrees. Likewise, we could actually fill in this one. 2 pi radians is 360, right? So if this is 1 pi halves, 2 pi halves, and this is the simplified version, then down here is 3 pi halves radians. And the next one would be 4 pi halves, but that's equal to 2 pi. And we do need to reduce all these fractions. Okay, the next easiest one to do is all of our multiples of 60. And every multiple of 60 is another pi third. So this is 1 pi third. 120 is 2 pi thirds. 180 would be 3 pi thirds, but we've already filled that in as 1 pi. Going another 60 degrees, down here would be 4 pi thirds. Okay, then we would have 5 pi thirds at 300. And 6 pi thirds, which is the same as 2 pi, is 360, right? We've already filled that one in and reduced. Okay, next let's do all the multiples of 45, which is pi over 4 every time we go 45 degrees. So 1 pi over 4. 90 degrees would be 2 pi over 4. And this one would be 3 pi over 4. 180 would be 4 pi over 4. 5 pi over 4 for 225. 6 pi over 4, which we've already done for 270 and reduced. 7 pi over 4 at 315. And then 8 pi over 4, which we already have the reduced 2 pi version of. So the reason we're starting with 90 and then 60 and 45 is we'll have less reducing, right, as we get around to all these. 30 degrees is a pi over 6. So every 30 degrees we go, think it's another pi over 6. So 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6 we hadn't filled in. 6 pi over 6, 7 pi over 6 we had not filled in. 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, and this would have been 12 pi over 6, or 2 pi. Okay, so now we filled in all the radian measures. And the more you practice these, obviously, the faster you will get. with doing some of these. So it's always recommended to print out kind of some multiple unit circles and practice filling them in. Usually in person, we give you a unit circle and give you like 4 minutes to fill all of these values in. And we've only just done the angles and one quadrant of values. Okay, now that we filled in all the angle measures, we alluded to last time that all of the other values, sine, cosine, and tangent, can be filled in using symmetry, right? Now, outside of quadrant 1, some of these values might be negative, right? The x or y coordinate might be negative, so we might get a negative cosine or sine value. And tangent can be negative, depending on if we're dividing a positive divided by a negative would give me a negative answer for tangent. So let's look at some of these things. To help remember if sine, cosine, or tangent is positive or negative in each quadrant, we can use the phrase, all students take calculus. All students take calculus, starting in quadrant 1 and going counterclockwise, just like our angles go. So the A in all, or the whole phrase actually all, lets us remember that in the first quadrant, sine, cosine, and tangent, all three are positive, right? Quadrant 1, x, y, and a positive divided by a positive, they'll all be positive in quadrant 1. In quadrant 2, the y coordinate is positive, right? Our x's are negative and the y is positive. So sine, the y coordinate, is positive, but cosine is negative. And when you do tangent, which is sine divided by cosine, a positive divided by a negative is negative. And so what this tells us, the only one of those three that's positive in quadrant 2 is sine. So the S in students help us remember sine is the only positive one in quadrant 2. Therefore, the other two are negative. Okay, T for take, as you can imagine, is tangent. That's because both x and y, cosine and sine, are negative, but a negative divided by a negative is positive for tangent. Remember, tangent is sine divided by cosine. And in quadrant 4, the x coordinate's positive, but y is negative, right? So cosine is positive, but sine and tangent, when we divide those values, are both negative. So all students take calculus. Helps us remember what's true about each quadrant. Okay, so trying to memorize every trig value on this unit circle can be pretty taxing. So we're going to use what's called a reference angle eventually to help us fill those things in. But let's go back and fill in all of these other values, and I'll show you how symmetry will make these easy. If we take these values in the first quadrant, which we need to know how to derive with the left-hand trick or whatever other form you want to use, we're going to take this point, let's say 60 degrees, and if you go straight across, straight line across, we end up hitting 120 degrees. The x and y values will look the same. So I get to copy that 1/2 and root 3 over 2 that we saw over here, right? I kind of go straight across. However, in quadrant 2, all of the x coordinates, right, we're to the left of the origin, all the x coordinates are negative. So this is actually negative 1/2, but all the y coordinates are positive. So likewise, if we go straight across here, I can copy our values of root 2 over 2 and root 2 over 2, but all the x coordinates are negative. So likewise, going straight across here, we get root 3 over 2 and 1/2. X coordinates are negative. Over here, we have 1 and 0. Again, you can go straight across, or hopefully you just know this nice coordinate point would be negative 1, 0. Okay? So likewise, now to fill in ones in the bottom, you can either go straight down from our values in quadrant 2 or straight down from our values in quadrant 1 to fill in our other ones. So if we kind of copy the ones that would be straight below each other, root 3 over 2 and 1/2. I'm going to come back and do the signs at the end here actually. Root 2 over 2 and root 2 over 2. Again, we're just going straight down. And then 1/2 and root 3 over 2. Okay. But remember, down here in quadrant 3, both sine and cosine, the x and y values, are negative. So these are both negative values. Okay. In quadrant 4, if you copy these straight down, or you can go straight to the right from quadrant 3, this would be root 3 over 2 and 1/2, root 2 over 2, root 2 over 2. So again, you can see we're using kind of that symmetry, like if I folded these things over the x or y axis, we'd get these values. Now remember, in quadrant 4, only the the y coordinate is negative. Well, not only, but the y coordinate is negative. The x coordinate is the only positive one, right? Think of our all students take calculus, which I'm going to write in here. All students take calculus. So only tangent's positive here, and calculus, only cosine, the x coordinate, is positive here. Okay, so there's a couple of things we hadn't filled in yet, like our tangent values. Now the x and y coordinate here would be 0, -1, right, for our y coordinate. Now tangent values also copy over. So this would be root 3, copy straight across, would get 1, root 3 over 3, and 0 at pi. Now remember that, again, only sine is positive. Tangent is going to be negative here. So let's make all of our tangent values negative. -0, not really necessary. Okay, in the third quadrant, again, I can copy these straight down. You can even actually follow these lines diagonally if you'd like, right? Those values will match up as well. But I'm going to go straight down. I get root 3 over 3, 1, root 3, and in fact, even undefined. Tangent is always undefined on the y-axis here. Now, in quadrant 3, tangent is the only positive one. So these are all positive. And in quadrant 4, using some symmetry to fill these in, root 3 over 3, 1, root 3. In this quadrant, only calculus, cosine is positive, so our tangent values are negative. And so this is how we can fill out all these values. Now, what if on a test, I ask you to find what is the cosine of 4 pi thirds radians? Well, unless I have a whole unit circle in front of me, it's going to be very hard to fill in an entire unit circle and find the x coordinate of that point, which would be negative root 2 over 2. So there is another way to find these values, and those are reference angles. Now, what we're going to use is the fact that after we filled in the first quadrant, every other value, right, the values talking about the x and y, or cosine, sine, and tangent, all match these values, but might be positive or negative depending on where we are in the rest of the unit circle. So if my angle is outside quadrant 1, we're going to use what's called a reference angle, and we're going to reference the value it matches with in the first quadrant. And the way we do that is we figure out how far away my angle is from the x-axis. It's the closest it is. In other words, if it's 30 degrees away from the x-axis, its values are going to match these two, but might be positive or negative. So for instance, 330 is 30 degrees away, and check it out, it's got those matching values, except the y-coordinate sine is negative. If we're 30 degrees away from here, here, or here, all of these values that are 30 degrees away all have an x-coordinate of root 3 over 2, a y-coordinate of 1/2, right, cosine and sine, and a tangent value of root 3 over 3. Just some of them are negative, some of them are positive, depending on which quadrant we're in. But if we remember the all students take calculus, we can quickly figure out that sign. So this is what a reference angle is, and we're always going to use how far away are we from the x-axis, the shortest path back to the x-axis. Okay, so when we defined, on our previous one here, the reference angle, it's the angle, the one we're referencing, it's the angle in the first quadrant with the same fraction coordinates as the original angle. It's always positive, and it's 90 degrees or less because we're referring to something in the first quadrant. So let's figure out how to find reference angles. One, we're going to identify which angle on the x-axis our angle is closest to. So think about like when we're on the x-axis in the unit circle here, I've got kind of two measurements, but I guess really three. Are we closer to 0 degrees, 180, or 360? Those are values that would be close to on the x-axis. And whichever we're closest to, we'll use as kind of our reference angle. So let's try this first one. Find the sine of 120 degrees without using the full unit circle. So sine of 120 degrees. So first thing I have to figure out is kind of which quadrant we'd be in, which would be over here, right? 120 degrees is past 90. Remember, this would be 90, this would be 180. So we're between those, we're kind of in quadrant 2. So what are we closest to? 0 degrees, 180, or 360? In this case, we're closest to 180. So how far away are we? We are 60 degrees from 180, right? And so that distance, 60 degrees, is the reference angle we're going to reference from quadrant 1. So this is where you can use that left hand trick, right? Remember we said have your palm facing towards you. In this case, 60 degrees would indicate your index finger or pointer finger. You would fold that down, and sine is the number of fingers left up on the right. Remember the format is kind of square root of blank over 2. So if you fold in your pointer finger or index finger and count the number of fingers up on the right, you should have 3 remaining. So our reference angle from this quadrant, right, sine, in other words, what we just figured out is that the sine of 60 degrees is root 3 over 2. So I have the right fraction. Now I need to remember, is this fraction positive or negative in quadrant 2? And so that's where, again, we can go back to all students take calculus. So we're in quadrant 2 at 120 degrees, and only sine is positive. Well, what we're referencing is sine. So in quadrant 2, sine is positive. So our answer is positive root 3 over 2. Okay, now if we were in a different quadrant, 60 degrees away from the x-axis, maybe my answer is negative, right? But we can use that value that we can use with our left hand trick to come up with root 3 over 2 for sine of 60, the reference angle, and then figure out if it's positive or negative using this all students take calculus. Okay, let's try another example. Let's say I want to find the cosine, which is the x-coordinate, of 330 degrees. Note, again, we are outside of the first quadrant. You don't need to use a reference angle if you're in the first quadrant because it's its own reference angle, right? So the first thing to figure out, how far away from the x-axis are we? Are we closer to 0, 180, or 360? We're definitely closest to 360. So how far away are we from 360? We're 30 degrees away. And so we're going to use 30 degrees as our reference angle in the first quadrant. So let's reference the cosine of 30 degrees. So let's find our reference angle. Okay, so 30 degrees, when your palm again is facing towards you on your left hand, if you fold down your ring finger, that would be 30 degrees. And cosine is on the left. So remember, it's square root of blank over 2. So count the number of fingers up on the left. 1, 2, 3, thumb, middle, and index finger. You get root 3 over 2. Okay, so that is the x-coordinate of 30 degrees in the first quadrant. But my angle is really 330. So where are we at 330? We're down here in quadrant 4, right? We're between 270 and 360. So in quadrant 4, cosine is positive. Wow, we didn't have to change our sign at all. Cosine is positive. So our actual angle of 330 degrees happens to also be positive root 3 over 2. Okay, let's try a few more examples of these. What about tangent of 225 degrees? In fact, let's change this example. So I apologize, you'll have to change this on your worksheet as well. Let's do tangent of 150 degrees. We're going to change it up a little here. So we'll have to change this to say 150. Okay, so a tangent of 150. So first thing, are we closest to 0, 180, or 360? We're closest to 180. How far from 180 are we? We're 30 degrees away. So we're going to use 30 degrees as the reference angle in the first quadrant. So let's figure out what is tangent of 30 degrees. Now, the tangent values you may just need to memorize, right? Sine and cosine, we can use the hand trick, but tangent we need to memorize. Tangent of 30 degrees is root 3 over 3. So this would be our reference angle. Now, our actual angle, 150 degrees, is in quadrant 2, right? We're between 90 and 180. And in quadrant 2, sine is the only positive value. All students take calculus. So because sine is the only positive one, we know tangent, quadrant 2, is negative. So our actual angle, and you can check this on your unit circle, tangent of 150 degrees is negative root 3 over 3. Okay, well, again, once we get this process down, it saves you so much time because you don't have to rederive a full unit circle to find a lot of these values. So now they've given me one in radians, and they've given you a hint, convert to degrees first. So 7 pi fourths, you can think of, I guess, pi fourths is 45 degrees, right, itself. So you can say we have 7 of them and multiply, or I actually know that if this was 8 pi fourths, that's 2 pi. That's a full circle. So I could also think of I'm 1 pi fourths short, 45 degrees short of one full circle, which when you work with these enough, you'll figure out is 315 degrees. They're essentially asking me to find the sine of 315. Okay, so we can just do conversion, whichever way you want to do the conversion, but that's sine of 315 degrees. So is 315 degrees closest to 0, 180, or 360? Definitely 360. And we are, in fact, 45 degrees away. Right? So we are going to use 45 degrees as our reference angle. So let's find the sine. Let's reference the sine of 45 degrees. Okay, so you can use the left hand trick. 45 degrees is the middle finger, and sine is on the right. So we would have square root of 2 fingers left up on the right, over 2. So in fact, sine and cosine here are the same, but we wanted sine, square root of 2 over 2. However, our angle, 315 degrees, is definitely down here in quadrant 4, right? All students take calculus. In quadrant 4, only cosine is positive. In quadrant 4, sine, therefore, is negative. If only cosine is positive, sine and tangent are negative. So our actual angle, the sine of 315 degrees, is negative root 2 over 2. Okay, we'll definitely do a bunch more examples with this in class. Write down any questions you have or confusions. Please include them in your discussions, but also write them down to make sure you ask them in class. It's really, really important to understand where all these values come from in the unit circle, right? How to fill them in. Usually we have a speed test of filling all of these 80-something values in, where you have like 4 minutes to fill them all in using symmetry and deriving the first quadrant. So it's really, really important that you understand these. Anytime you're working with trig later on, you're going to need to know how to do these things again. Okay, so have questions. We'll see you in class.